Okay, example 19, number 4. Okay, find the limit of x approaches negative infinity. Alright, so for the function x plus 1 over square root x squared plus 1. Alright, so for this question, if we substitute directly the limit which is negative infinity, we will get infinity over infinity, which is an IDF. Right, so that's mean we cannot substitute yet our limit. We need to divide each term with the x to the highest power for the denominator. Alright, so for this question, okay, the highest power of x at the denominator is square root x square. Okay, square root x square. Okay, and square root x square is not equals to x. This is equals to modulus x, or the absolute value of x. Alright, it is different with square root x square. Okay, this one is x, but for square root x square, this is modulus x, so we have a different value here. Okay, so not the same. So now we're going to divide each term by square root x square, which is a modulus of x. Alright, so that's mean each term must be divided by square root x square. So we're going to write here, okay, limit of x approaches negative infinity. Okay, so up here we divide by square root x square, and down here at the denominator we also divide by square root x square. Alright, so for the denominator, okay, here, this part, okay, we can use the properties of surd, which is if we have square root a over square root b, this is also equals to square root ab, right? So that's mean we can bring what inside the square root into the other square root. Right, so at the denominator here, okay, so I rewrite here limit of x approaches negative infinity. So for the denominator, it will become, okay, square root x square plus 1. Okay, everything divided by x square. Alright, so for numerator, okay, up here, this part, okay, that's mean we divide, okay, each term by square root x square. So we write here, so x is divided by square root x square, and 1 also divide by square root x square. And we know that square root x square is actually modulus x. Okay, so square root x square is equals to modulus x, and we know the absolute value of x, okay, you're going to have two value, whether it is a positive x or that is a negative x. Okay, so that is a positive x is greater and equals to 0, and negative x for x less than 0. Right, so we need to determine here. Okay, I will rewrite again this. Right, so for denominator, I can simplify first. This is 1. Okay, so this is equals to limit of x approaches negative infinity. Okay, x, okay, this is over modulus x. Okay, 1 over modulus x over, and the denominator is 1 plus 1 over x square. Alright, so for modulus x, we need to change whether it is a positive x or it is a negative x. Okay, we need to change modulus x whether it is a positive or negative x. So which one we're going to change? So we need to look at x. Okay, so x is approaches negative infinity. So in the number line, okay, 0 is here. Okay, so when x is greater than 0, this is for x. When x is less than 0, negative x. So since x is approach negative infinity, which is x is moving to the left. Okay, that's mean it go to the territory of negative x. So going to the left, so modulus x must be negative x. So we're going to change modulus x as negative x. So this will become 1 over negative x plus 1 over negative x. Right, so we can simplify here. This is 1. Okay. This is, okay, I will write this is limit of x approaches negative infinity. Okay, up here we have negative 1 minus 1 over x over square root 1 plus 1 over x square. Alright, so remember when we deal with square root x square, okay, square root x square is modulus x, and modulus x is either positive x or negative x, so depend on which direction x is approached. Alright, so to make things simple, okay, if x approach positive infinity, okay, modulus x will be x, and if x is approaches negative infinity, okay, so modulus x is negative x. Alright, so now we can substitute the limit, which is negative infinity. So we get negative 1 minus 1 over negative infinity over square root 1 plus 1 over negative infinity squared, and 1 over infinity is 0. So what we left here is negative 1 over square root 1, which is negative 1. Right, so the limit is negative 1.